To solve this problem, which one of the following is not involved in the secretion of K plus from blood into tubular fluid by the principal cell of distal tubule? So here our answer is third one, that is 1 Na plus 1 K plus 2 Cl minus sym water NKCC2. Okay, so we have to go much details of this question to understand what the question demand, and if the question repeat in other examination, it would be easy for us. So the question is asking about secretion of K plus from blood into the tubular fluid by the principal cell of distal tubule, for that which is not involved. So for that we have to first check where does this K plus secretion occurs. Okay, in nephron there is principal cell of late distal tubule and collecting duct. Okay, in nephron there is a principal cells of late distal tubule and collecting duct. So they are the major cells responsible for secreting K plus from, that is potassium, from blood to the urine. Okay, if you understand that basic concept, we could move on to much details of what is that principal cell, the composition, not composition, what how does the movement of the different this potassium occurs. So that we have to understand that there is the principal cell. Okay, here it is the principal cell, and for the principal cell there are two sides. One is blood side, another is the urine side. Okay, the blood side is the basolateral membrane, then the urine side is the tubular lumen. Okay, urine side is the tubular lumen. Okay, so these are the principal cell layout. Then next we have to look into how the potassium movement, ion movement that happens in this principal cell layout. First of all, the from the blood side, that is from this basolateral membrane, the potassium ion enters from the blood to the cell. So the cell must take K plus from the blood. Then this principal cell, in that the K plus moves. So move K plus into the cell. Then release K plus into tubular fluid. That means in the to the urine side this K plus ion is released. Okay, so that the blood the K plus ion now moved from the blood side to the urine side. I hope you understand this. Then moving on, we could check how the K plus enter the principal cell. That is the first step. So from the blood side, the K plus ion moved into the principal cell, that enter the principal cell. How it occurs? So there is a pump. There is a pump that is Na plus K plus ATPase pump on blood side. On the blood side, on the basolateral side, there is a Na plus K plus ATPase pump is there. Okay, using this pump, 3 Na plus is going out of the cell and 2 K plus is entering the cell. Okay, 3 Na plus is going out of the cell and 2 K plus is entering into this cell, principal cell. So that would create high intracellular K plus concentration. Okay, that would create high intracellular. That means inside the cell there would be high K plus concentration because of this step. Okay, then from the blood we know that this Na plus K plus ATPs help help the principal cell to take the K plus into from the blood to the principal cell. Okay, so now the principal cell full of K plus. That is the thing we have said now. And at last, the last point we have said is that now the K plus ion is there inside the principal cell in abundance. So this is the driving force of K plus secretion, that is potassium ion secretion. For that the driving force is this. Okay, second thing we have to look is that how does this K plus leave into the urine, that is onto the urine side, how it is moving. Okay, how does this K plus leave into the urine? So potassium ion exit through the potassium channel on the luminal membrane. So there is a luminal urine side. We have said that in the urine side there is tubular lumen. So on that tubular luminal membrane there is a potassium channel. So K plus exits through this potassium channel to the urine. Okay, there are two important channels present there, where in the luminal membrane there are two important potassium channels present through which the potassium is exiting from the inside the cell to the urine. Okay, one is ROM, this is R. Okay, ROMK channel, that is renal outer medullary potassium channel. Okay, that is the main channel for normal potassium ion secretion. Continuously secrete the potassium into the urine. So it continuously secrete the potassium ion into the urine. Which channel? ROMK channel, renal outer medullary potassium channel. Okay, then next is the BK channel, that is big potassium channel. Big potassium channel that activated during high tubular flow. When there is a high tubular flow and high potassium intake is there, there is need of high potassium outtake also need to be happen there, because high potassium intake is happening in the cell. So when there is a high tubular flow and high potassium ion intake, there always they activate the BK channel. This activate the BK channel that led to always large K plus secretion. That always large, that will lead to always the to the large K plus secretion. Okay, for both one, what happen is that from the cell to ROMK channel to the urine. If it is BK channel is activated, then cell to BK channel to the urine. Okay, then both directly participate in K plus secretion. So we when move to the question is asking which is not involved in the secretion of potassium ion from blood into tubular fluid by the principal cell of distal tubule. So we could eliminate the big K plus channel, BK channel, and the ROMC channel because they participate directly. Okay, next we have to look is the KCCL channel. So that is what is KCCL channel? That is potassium ion chlorine minus co-transporter. Okay, potassium ion and chlorine ion co-transporter is this KCCL. Okay, it transport K plus and Cl minus to to where they this through this channel, through the KCCl channel, the potassium and Cl minus is transported together. They are transported together. So they are found in many cell. One of the cell is renal epithelial cell. So it is also participating in the potassium ion transport. So we could eliminate that option also. This help maintain the intracellular ion balance and can contribute to K plus movement across membrane. Okay, hence it can be involved in potassium handling. So we have to eliminate other option also. K plus Cl minus co-transporter. This also there in the potassium ion transport from blood into the tubular fluid by the principal cells of the distal tubule. So left with one option this. We have to take that because not involved is the question. So we could look into what is the purpose of NKCC2. Okay, for that NKCC2 is to transport Na plus K plus Cl minus. Okay. Sodium, potassium and chlorine, 3 are transported by the NKCC2. So found mainly in the thick ascending limb of the loop of Henle. In the loop of Henle, there is a thick ascending limb. There it is found, which found NKCC2 found. Okay, it is not present in the principal cell. So we could check what is the function of NKCC2. Okay, the function of NKCC2 is the reabsorb the Na plus K plus Cl minus from tubular fluid. From the tubular fluid to reabsorb the Na plus K plus Cl minus. Okay, not the secretion. Okay, it is to reabsorb the Na plus K plus Cl minus from tubular fluid, and it is important for the urine concentration. To concentrate the urine, this is important NKCC2. So it is the target of loop diuretics like the furosemide and bumetanide. Okay, for this diuretics that targets this NKCC2, it is targeted by those. Okay, so moving on, we have to check one more, the potassium secretion by principal cell requires. That is, we are summarizing this. Potassium secretion by principal cell requires Na plus K plus ATPs, that is from the basolateral side, then ROMK channel and BK channel on that lumen side, then aldosterone that stimulate the secretion. This is an add-on information, aldosterone which stimulate the secretion. Okay, the question is asking about secretion of K plus from the blood into tubular fluid. So we know that the third option, 1 Na plus 1 K plus 2 Cl minus importer, that is NKCC2, is not in the secretion of K plus, but it is for the concentration of the urine. Okay, it reabsorbs the K plus. Here when we look, it reabsorbs the Na plus K plus Cl minus from the tubular fluid, that is from this urine. Okay, this all about this question, and we have to we got the answer as third one, that is here option 3. This one I would highlight. This is sorry, this is our answer. Okay, I hope you got it.